So that's what a radian is. A radian is a measure of an angle. That, let's say that opens an arc that has the same linear measure as the radius of the circle. Okay? Now, let's see here. If that is what a radian is, it's this angle right here. I was practicing this yesterday, so let's see if I can manage this again today. I'm going to try this. What if I take that angle, okay, and I rotate it? Let's see, is that going to work? Yeah. And I put another angle right beside it, the very same angle. You see what I did? Okay. Question is, how many of those could I fit all the way around the circle? So here we go. Let's take another one. Let's move it over here. Let's rotate it. Okay. How many do I have so far? 3. 1, 2, 3. Okay. Let's take another one. And we'll bring that over here. How many do you think I can get in here? 7. Okay, let's see if we can get 7 in here. First of all, let's see if I can get this one in there. There we go. A little bit. How many do I have so far? 4? Okay. So let's try this one more time. And we'll bring this, oops, we'll take that down. Let's take this down. And let's rotate it so that it is identical to that. How many do I have so far? 5. Someone said 7. Do you still think I can get 7 in there? Didn't sound as sure that time. Okay. So I've got what, 5? Okay. So let's try this one more time. And we'll take this, oops, take it again. Come on, there we go. And let's rotate it. Move it up here. We'll rotate it again. I don't know about that 5, that 7. I have, let's count them here. I've got, we'll put it in green, I guess. I've got 1, 2, 3, 4, 5, 6, but that doesn't look to be the same measure as the others. Okay? Doesn't seem to be the same. Let's decide exactly how many, and you already know the answer. You already know the answer. Okay. Let's look at our proportions. Now we'll put it in green. Let's look at our proportions. I'm going to need that after all. This is kind of a cute little dealy bob. Let me just show it to you. Look at that. Look at that. I can just draw anything I want. I like that. That's kind of cute. Okay, just playing around here. I want to get rid of it, though. There we go. Okay. I want to figure out exactly how many of those, and exactly is what I'm going for, exactly how many, but I want to know approximately too. Okay, so I've got, now we're going to set up a proportion. Not the linear proportion that I did when I was learning trig from a table. We're going to use proportions from what we know about angles and circles. So I know that the degree of my, well, you know what, I'm not going to have enough room there. So let me move this down, because I know how large of a writing it's going to take. Okay. There we go. If I take the degree of the angle is to the degrees of the circle as, okay, that's one part of my proportion, as the arc length of the angle is to the arc length of the circle. Now you might think, what on earth is she talking about? You already know this stuff. You do. You learned it back in probably upper elementary. Here we go. The degree of the angle, I don't know what that is. I'm going to put D there. What's the degrees of a circle? 360. Okay. What did we say was the arc length of that angle? 1. We created it so that the arc length was 1 unit. What is the arc length of the circle? What's another name for the arc length of a circle? Circumference. Yes, circumference. Okay, so this is nothing more than the circumference of a circle, and we're going to say where the radius is equal to 1. So, circumference of a circle is 2 pi r. If the radius is 1, 2 pi. Now, what am I looking for? The approximate degree measure of angle theta. Okay? Approximate or exact, depending on what we're going for. Okay, so the degree of the angle is 360 divided by 2 pi. All of you who had in your head 180 divided by pi were absolutely correct. And when I said, what is the approximate value of that, you said approximately 60, because pi is 3.14, 3.14159, whatever. So it's approximately 180 divided by 3, which would be 60 what? Degrees. Now, if we go back to our circle, if we now say that the this angle theta is about 60 degrees, then about how many of them should fit in the whole circle? 6, right? 360 divided by 60 would be 6. But we got this little bit left over right here. That's not a whole unit. That's not a whole 60-degree measure, so let's get a little closer approximation. So now take your inspires and let's get a better approximation. Now, if you want to get a decimal approximation, you have to do what? Control Enter, or put a decimal point at the end of 180. If you put a decimal point somewhere in that fraction, it will report back a decimal answer. And the answer is 57.3 degrees. So it's less than 60 degrees, which means that we would have more or less than 6 of those angles. More. Yeah. About how many more? Well, let's take a look and see. On your inspires, get an approximation for 2 times pi. Yeah, 2. 6.28. Okay. What does that 6.28 tell us about how many radians we have in that circle? 2 pi is approximately 6.28, which tells us what? Yeah, Nash. You were raising your hand, right?
No,
Oh, good. Okay.
6 and then 0.28 of that 6.
So about a fourth of another one of those angles in there. Not 7, like someone said, but about 6 1/4 of those angles. That's what that 2 pi is representing. So if you place that one angle, that very special angle, what do you call that special angle? We had a name for it. You had it just a minute ago. We call it a what? A radian. Yeah, we call it a radian. So we call it a radian because, why? Absolutely. Arc length is equal to, radian comes, no one told me this, I'm just making it up maybe, but it sure makes sense to me. It comes from the word radius. Okay, so think those two things go together. So if I place that angle around here, I'd have 6 1/4 of those angles. Now, why do we bother with doing things in radians and trig? Casey, what do you think? This is my so what. So you get this angle, big deal. Who cares?
It's probably a simpler number to work with in specific degrees.
Yeah. How old are you? How old are you?
Oh, I'm 19.
No, in seconds.
Wow.
You know, we don't do that, do we? We don't tell our age in seconds. We don't tell it in minutes or hours. And so it's the same thing here. We don't measure an angle always by degrees. We clump it into a thing called radian, just like Casey clumped his age in something we call a year. A year is made up of lots and lots of not millions, but lots and lots of seconds here. So the same thing here. So think of a radian as just another way of measuring an angle. It's a very special angle. It's about 60 degrees. More closely, it's about 57 degrees. And we have about 6 1/4 of those around the circle. Now, if I ask you this question again on another day, I want you to have now a better answer than you had before. Hopefully you will. Okay? Hopefully this will now, after you had it before and now you see it again, the second time around, it will make sense to you as to what a radian really is. It's just another way of measuring an angle. Amazingly, though, no one really knows what a radian is. It's that elusive name we give something that means nothing to us. Well, it does. It does now. Okay, let's go on. Whoops, I got 12 minutes here. We're going to go on to another important piece of trig review, and this is when we get into our actual trig name. So I'm going to be good here and stop.